It's a pleasure all to welcome you to Data Citizens, a distinguished lecture series. And today we'll be hearing from Nilam Ram as part of this IDIS series. And Nilam really is a data citizen and scientist. He is a professor in communication psychology at Stanford and has been since this fall. I knew Nilam at Penn State, where he's a top flight quantitative psychologist looking at processes of change. And in particular, Nilam is interested in the relationship between kind of what we might think of as small scale change, how we change in a given interaction, how we change in response to a phone call, for example. I'm trying to work in those screens. And larger scale change, how our emotion regulation might change in the context of aging, how a child might develop. So as I was saying, I know Nilam from Penn State in his work there. But before that, Nilam was actually, I guess, a currency trader, I think in New York City. I think I'm remembering this correctly. Yep. And, you know, interested in these processes of change and how small movements, let's say, of the market might contribute to larger movements, let's say, of the market. But, you know, unlike a lot of others with those kinds of quantitative skills, he really invested them, you know, in the pursuit of knowledge and asking those questions again about how first human movement can contribute to development, but how psychological processes and small processes of change can be related to development. And what I always like to say, actually, I'll make the argument here as part of my introduction, like we know that small scale change, like how you change in relationship to a partner or how you change in relationship to a student or professor, how be related to large scale developmental change, because after all, they're just different time scales, right? There's nothing different about time. The little stuff in your life, the little stuff in my life anyway, has to be related to the big stuff. It's all one big continuum of time. How we focus on it, that's just us. But time itself, that's what contains us. So with that intro, Nilam will be talking to us today about one of his new and exciting projects called Screenomics. I really have just a vague idea of this. But my understanding is that more and more of us live digitally and that we need new ways of understanding our digital life. So with that, please put away your cell phones and join me in welcoming Nilam Ram.
Thank you, Daniel. Thank you all. It's really a pleasure to be here and have the opportunity to talk to you. I've got a bunch of slides. I'm going to try to get through these as fast as I can. I'm excited about the question part of this because that's where I sort of learned the most, and you guys are at the forefront of what's happening on the computational side. So I'm curious on how those can get melded together with what it is that we're thinking about. Okay, so just want to start off with some thanks to the institutions that are supporting our work generally. And I'm lucky that I work with lots of collaborators, and my two collaborators here at Stanford, Byron Reeves and Tom Robinson, have been really instrumental in how it is that we're thinking about screenomics. And we've got a nice set of students and postdocs who are all working on this problem together. So this is really a group effort that I'm talking about here today. Just to give a little background on the perspective that I'm coming from. So as a quantitative psychologist who's interested in longitudinal data, my job is sort of to figure out change processes and how to model dynamics. And we forwarded a typology of those dynamics of 4 different types. Stochastic entropy type, one can think of that as random changes, stability maintenance processes like emotion regulation, incremental change processes like learning, and transformational change processes where we have some kind of a stage shift from one qualitative state into another qualitative state. And my work generally is thinking about how it is that we can articulate all of those different types of change processes within a differential equations framework. And that allows us to be able to study these different types of changes. So I'll quickly go through here a couple of examples, just taken from different areas. Stability maintenance, this is a measure of cardiac function. parasympathetic response to people watching movies, children watching movies. And then notice here that we've got 28 observations. So this is, in psychological science, we're trying to push the limits of the number of repeated measures that are available and how it is that we can make use of those in order to look at nonlinear relations. So here, the sphere clip, Disney's really good at creating climaxes and resolutions. So that's kind of what it is that we see in this type of modeling framework. Incremental change, here's pubertal change, growth in height. And here we're also trying to look at those context effects. How is it that the hormonal context is changing as individuals move through as their height grows and they have particular growth spurts? Also a nonlinear model. And then transformational change, we're looking at the onset of terminal decline. And here we get inter-individual differences in the moment in which people move from one stage to another. So here at the bottom, we can see somebody, we've got time to death along the x-axis here, life satisfaction along the y-axis. So some people enter into the terminal decline phase 10 years before they die, some people 2 years before they die, and some people never at all, presumably because they have died of an accident or some sort like that. So we're using that. And this is all just, I put this in German data here. Daniel is here, so I thought I'd talk about some data from mother-child dyads. This is categorical time series. So each row here is a different child, and they are in an experimental task. They're interacting with their mother in the first part of this task. Then the mother goes with a blank face for 60 seconds, and then she starts to re-engage with the child again the second time. And you can see here that there's this emergence of negative emotions, the red, which is occurring during the time when the mother is not responding. So we were excited. This is 300 occasions of measurement. So that's time series, but we're in a categorical space. So we have to figure out how to deal with the categorical nature of those data. And now we're moving to multinomial logistic multi-level regressions in order to be able to do that. What that allows us to do through some fitting in a Bayesian framework where we need that sort of regularization in order to get this many parameters out of the models. And we can see that actually what's happening is that there's a lot of decrease, that sort of positive affect, this positive emotion is getting sucked out of almost all of the children. They're like getting hit with a hammer here because their mothers are not paying attention to them. And then they need some time to recover from that. So what this has done for us in thinking about our framework is we've now got these categorical time series, and we're trying to pull out simultaneously stability maintenance about the emotion regulation pieces, incremental change, which is occurring across time, and transformational change that's induced by the switching of the mother's behavior as part of the context. So from those categorical type time series, we're able to pull out in this Bayesian framework individual trajectories. And one of the thing to note here is that there's a lot of heterogeneity in those individual trajectories. So this becomes interesting. That's even a homogeneous laboratory-based task with young infants. And now think about the amount of heterogeneity that we're going to see into the real world. So that's what brings us to what it is that I'm going to talk about today here. About 10 years ago, we were among the first groups that was starting to collect data using smartphones. And so we would give people smartphones at that time, and they would carry them around with them during the day, and they would answer questions every few hours about who they were with and how they were feeling about various psychological states, what the context was. And we used those data, which includes both the categorical time series, ordinal time series, and continuous time series, in order to be able to try to articulate these 4 different types of change processes. So this is 10 years ago, what it is that we were able to do with smartphones. At that time, we had to give people phones because not everybody carried them with them. Now, most of us are carrying at least 1, if not 2 of these types of devices. So this brings us to today, and what is it that we can do then on these smartphones? So what it is that you're watching here is a paradigm which we're calling Screenomics, where we install software on people's smartphones and we take screenshots of everything that appears on the screen every 5 seconds. And as Daniel alluded to earlier, sort of life now all different aspects of life are now represented on these screens. So we see interpersonal relations, we see movement through entertainment, we see health information. All of these different aspects of life are happening right next to each other on the same screen. So you pick your favorite phenomena that you're interested in. I'm interested in emotion regulation. So we can look for areas within the screen that we can see emotion regulation manifest in itself. So I often turn to cat videos as a way to regulate my emotions as we go forward. So there's a lot of privacy constraints in collecting these types of data. It's super rich. There's lots of information in there. It's all in this pixel format. So we've got tens of thousands of images per person, and we're trying to then extract out meaningful information from those. Down at the bottom, we've represented the type and color, the type of activity that the person is engaged in, what type of application is open, whether that's a communication app, a social media app, or a tools app. And the little fuzz that's on the outside of that, I like to think of something kind of similar to telomere length or something, but it's about the visual complexity of the screen. So what we're seeing, what we're trying to extract out there is how much information flow is hitting that person. And can we track that over time? Okay, so the general idea here is we're able to capture all of digital life, everything that appears on that screen 24/7. We've got 200 people in the field right now who have been sending us data for almost a year. They're about 1 month away from a year-long segment. And so this gives us real rich information on all of the things that you do on your smartphone. Okay, so what do we learn from this type of data? When we first started looking at it, a few of the things which really hit us were that all of the different domains with which we do study. So if we engage in studying different types of silos, so we might be interested in entertainment on the communication media side, in politics, in interpersonal relationships, in work and health. But on the smartphone, these are all happening right next to each other. So no longer are these silos happening at separate times. I have dinner and then I watch a movie. No, you're working, answering emails while you're having dinner and helping the kids with homework all at the same time. That's all occurring right next to each other. So the ability of the technology allows us to do what I'm calling here massively idiosyncratic engagement. So we're all engaged with context at different times in different places, different kinds of context in different times in different places. And for each of us, that's totally idiosyncratic. So we don't all sit down and watch the 6 o'clock news anymore. We're watching news all across the day at different times and different aspects of that news. And potentially what this means, because all of the different domains are happening right next to each other, is that there becomes a greater systemic interdependence in the way in which the dynamics operate. So the text message which you all have looked at while you're listening to this lecture influences how it is that you're going to perceive what it is that I say next. And what I say next is going to influence how it is that you read the next text message that comes into your phone during the course of this lecture. So that's sort of how things are playing across each other now. Okay, so 3 avenues that we're looking at. So we just talked about Screenomics as digital life, and our argument is that now, especially with COVID times, that digital life is life. All of life is represented there, and maybe this paradigm allows us to go a little bit further beyond digital phenotyping of persons and environments simultaneously. So we're trying to push the limits there. I'm going to talk a little bit about small data and our approach to big data and feature engineering and the AI that we're bringing to bear there, particularly person-specific models, now that we have very rich time series. And then I'll give some examples of the temporal complexities that we're seeing in our data streams. Okay, so the term big data expresses the potential of extracting meaning and value using data sets covering large numbers of people, or a large N. The big data houses here in Silicon Valley have sort of banked on collecting data from lots and lots of people. Big data's humbler counterpart, small data, promises to be equally transformative, allowing individual users to harness the data they generate through their own use of online and mobile services, or in other terms, when n equals 1. So our objective here is to get massive time series on individual people and try to treat those as a big data set in and of itself. So here's an example of an individual screenome. We've got time along the x-axis here. So this is midnight to midnight, and each row is 1 day. And the black indicates when it is that the smartphone is on, and the white indicates when the smartphone is off. So we see that there is lots of use of the smartphone happening here. There's lots of chances that life and all of the things which we do in life are being expressed onto that screen. Interestingly enough, this is an adolescent, and it's also hard to tell when it is that they are in school and when it is that they are sleeping. There's so much use which is occurring on these smartphones. Okay, so how is it that then we extract data from here? We've got those images now, and each one of those images, we can pull out a variety of different features from them. So I'm excited because our postdoc, MJ Cho, has just rewritten our extraction toolkit. So now we're able to pull out even more features that have even better accuracy than we had before. So we can pull out low-level graphical features. So this is a relatively black screen, homogeneous in color. So it has relatively low entropy. This screen on the left is more complicated visually. So it has a higher color entropy. More colors are represented there. And that gives us a time series then of the amount of information flow that is hitting a person's eyes, as it were. We can also pull out high-level graphical features. So here we've done object recognition. So this is the YOLO version 4 that we're applying here. And now we can start to characterize what are the types of objects that a person is seeing on their screens. One thing which we can identify relatively quickly is whether a person is a dog person or a cat person based upon the number of dogs and cats that appear in their screenome. And even though we're in a period of isolation, we have started to think about how many people it is that we are getting exposed to through the media images that we're looking on these screens. So we can identify here, for instance, people and characterize whether a person is actually seeing a lot more people versus a person who's not seeing so many people. Or days in which you have lots of social interactions through the phone versus not, et cetera. Okay, we can also pull out high-level graphical features like faces. Here we've gotten interested in, can we characterize the diversity of faces that a person is exposed to, the gender distribution of those, and also the emotions, the different types of emotions that people are being exposed to. So if we believe that you are what you eat, then the stuff that you are being exposed to on the phone will potentially have some input into the way it is that you live your life or how it is that you feel. So those are the types of things which we're trying to extract. And you'll notice here that not all of these are perfect. So the face recognition modules, the open source ones that we're using are not perfect, but was getting us closer towards where we want to go. And of course, we're always interested in how do we collaborate in ways that allow us to extract out more meaningful and more precise information from all of these millions of screenshots that we have now. Okay, we can also pull out all of the text. So using optical character recognition, we're pulling out all of the text from each of those screenshots, and then that becomes searchable, and we can start to do things with that text. For instance, we can simply count how much text there is. This screenshot has 25 words on it. The screenshot on the right, Instagram, only has 1 word on it. So that's also a measure of information flow. And then also the content of the text has some psychological meaning to it as well. For instance, the Pennebaker work using the linguistic inquiry and word count is the number of pronouns that people have in their writing or on their screen may give some indications about psychological state. So there's lots of other things that we can also do with that text. And we just hooked up with a group here led by Johannes Eichstad at Stanford to do some more things with the NLP side of this. Okay, so if we extract out all of those features, and we're pulling out about 1,000 features now from every screenshot, and then we can use that in order to label our screenome. And here we've just represented it as visual complexity. And then those are features we need to impose some interpretation on how it is that we think about those features. Other ways in which we're thinking about doing this is that we can take our raw screenshots on the left and we can pull out different kinds of features. So we can pull out a graphical feature vector. So these are Gabor filters that give us some indication about the graphical elements that are in each screenshot. We can pull out the text and we can compute textual features. And we can also use autoencoders in order to pull out thousands, tens of thousands of latent variables that we don't necessarily know the meaning of, but we can still use those in order to do classification further down the pipeline. So then we are doing some clustering there. And part of the difficulty has been each research group that we interact with has a different content area that they're interested in. And we're trying to figure out how do we pull their specific content area out of the screenshots. So we can do some clustering in order to get some help. And then we only need to label the centers of those clusters or the edge cases on those clusters. So then we sort of put this within an active learning paradigm in order to get back out some classification cases that then we can use in order to propagate labels across the entire data set. And because these data have such privacy restrictions on them, we can't do the labeling externally. We have to only do the labeling internally. And so this has really helped in us being able to label much less data in order to be able to get the ground truth that we need for propagation through the rest of the data set. Just to give some examples of the stuff that might come out of this is that this is one person's data, and then we've done this in a semi-supervised way. So we pulled out information about different types of screens. So the home screens, every person has a home screen, but every person's home screen is different from every other person's home screen. So there's an idiosyncratic component here. We were interested in food and how the food diet comes up. So I'll give an example of that. And then also my colleagues who are interested in visual interfaces are interested in the way in which visual stacks are created as a user interface by many different types of applications. So that has also popped out in these topics that we're extracting. An interesting piece here is that I have come from a tradition of trying to figure out how to do person-specific modeling with the idea that we need a different dynamic model for every single person. And so I was interested in whether we should be fitting our machine learning models for doing classification on the entire data set, or do I do a separate model for every single person? And in this particular case, we were trying to understand when it is that a person switched from one application to another application. And our group models provided just as good a fit as the idiosyncratic person-specific models, which was good from the sense that then we need to label less data, but I was disappointed because I was pushing this person-specific technique. And I'm happy to talk about that more. We realized since then that it is sort of idiosyncratic to this particular problem that we were working on that's really driven by one feature. So if I have major feature and that's consistent across all people, then I can work with the group model. However, if the feature which is doing the best prediction is different across people, then I would need person-specific models and potentially person-specific labeling. Okay, so to go through some other ways in which we're doing this, pulling out from the text, we're doing a dictionary lookup, talked about doing producing ground truth labels, and also ethnographic analyses have been really important. We make movies of these screenomes like I showed you, and just trying to figure out what it is that we should be pulling out from these data has been interesting. We were interested in food in one, and our ethnographic analysis led us to the conclusion that there's a lot of food and drinks that are embedded in our devices that we're getting exposed to, and those potentially have influence on our everyday eating behaviors. And drinks are almost always branded when they are shown in pictures. whereas food is almost always unbranded when it is shown in pictures. So there's also some industry interest in what it is that one can learn from the screenome about how it is that advertising and so forth might change depending upon what we find in people's screenomes, targeting as it were. Okay, we can also look at the sentiment of the text, et cetera. So just to give one example of that, here's one person over a period of about 1 day. And each bar represents when it is that the screen is on. And the color of the bar indicates what type of activity they were engaged in, whether it was a social app like Snapchat or whether they were playing a game. And the pink indicates that there was some type of food-related content on that screen at that point. So for this person, 38% of the screens which they're looking at, this is every 5 seconds, is got some food on it. So that's a very large proportion of the media input that has food in it. And the black sprinkles, which is chosen in the visualization here for the pun that's intended by putting some black sprinkles onto my banana sundae here, gives an indication of what the sentiment of the text is in those screens which have food-related content versus the screens that do not have food-related content. And there is greater positive sentiment associated with the food-related content than with the non-food-related content. So there's a pairing happening in the media here between the sentiment, the positiveness of the content, and whether it is food-related or not. So that will implicitly, theoretically, that will implicitly influence how it is that this person is engaged with food in the real world as well. Some other couple pieces, natural experiments. So here's a paradigm where we want to study rare events, how it is that you're exposed to a particular kind of message or media, and that happens very rarely in the real world, actually. So here we were interested in predatory payday loan ads and how it is that those might be affecting people who are in different economic strata differently, whether the exposures are different across different economic strata. So is there an information divide, as it were? So this is way less than 1% of the content. So imagine in your lifetime on a phone, how many payday loan ads have you been exposed to? We're trying to find those needles in the haystack and use those in order to look at experiments. So just to give an illustration of how this works. Here's one person's screenome across 62 days. We've got midnight to midnight along the x-axis, and each row here is 1 day. And we're looking for those specific places within here where the person was exposed to a payday loan ad. You know if you can see, there's one little red dot down here. So let's pick this 30 days and we can zoom in. And this is what's so beautiful about collecting data at 5-second intervals, is that we can zoom in to all of these different timescales and investigate phenomena that occur at those different timescales. So there's 30 days. We can identify a exposure to a payday loan ad by these red triangles. We can select that section of the screenome and we can zoom in further. So now this is over 14 days, the exposures that this person had to payday loan ads. And then we can even zoom in and let's look at the specific exposure and let's do the natural experiment of what was the content which was on the screen, how they were engaging with the screen in the 5 minutes prior to the exposure and the 5 minutes after the exposure. And in this data set, we find that there is a decrease in the number of future-oriented words, which is potentially a marker of cognitive state. Being exposed to the payday loan ad brings one out of the future and into the present, is the implication which is given here. And it turns out, oops, I think I missed a slide in here. I didn't include it. This effect differs on whether one is receiving social support or not receiving social support. So that individuals who are not receiving social support are at greater risk of this decrement in their future orientation than people who are receiving social support. So it's a way in which we're then using the screenome with its intense data collection in order to pick out these rare events and pick your favorite rare event, and there's possibility to study that here. Okay, now when I was interviewing at Stanford, I was sitting in an office, and a person, a researcher who studies genetic stuff, and they had a genome up on the wall, and all of my representations of the screenome have been linear left to right for time. And I realized sitting there that no, actually the genome, the double helix shown here, has all of these loops in it. And so what does that mean for time and our conceptions of time? As is time looping back and forth? So imagine if you get sucked into the YouTube black hole, then you're on one of these great big loops that doesn't actually could come back to where it is that you intended. Or can we do some things to shorten the size of these loops? So this sort of nonlinearity in the time dimension became of interest of how it is that we might look at things. So I'll talk a little bit about that. So one is a global temporal structure. Here's one person over 7 days. The different colors represent different kinds of applications. And then we've also pulled out from the text different topics. Purchasing, nutrition, public affairs is like politics. And the key point is that that's not app specific. So nutrition information is spread out across all kinds of different applications and across the day and temporally. So things are not happening in chunks, they're happening in this very idiosyncratic exposure ways. But notice that all the lengths of time that a person is engaged with their phone differ. So some of them are very short, 5 or 10 seconds, and other times they're onto their phone for 2.5 minutes. Nobody's on their phone for 2.5 hours straight. There's all of these breaks which are happening. So we wanted to check to see what the attention looked like. Here's the different classifications of different types of applications that a person is engaged with. It turns out that this looks to be log normally distributed, so that each person has about 30 to 50 apps in their app ecology. And the distribution is like we would see in bubbles as well, that there's some big bubbles and then there's smaller bubbles going on. The key is that everybody's is different, even though there might be these global statements that we can make when we abstract out quite a ways. We're interested in this behavioral inertia piece, or momentum, or what we've started calling screenertia. Is the media sticky, so that if I am engaged with Reddit, for instance, do I stay in Reddit, or can I move to something else, a different kind of activity? And media designers, of course, are interested in making things sticky, but we're also worried about the addiction piece and whether people are spending too long in particular types of applications, whether we might want to change that piece. So we wanted to see if people were actually engaging with smartphones in a different way than they were with other media or with other activities. So we can now do this at the individual level because we have so much switching information. So to each person's data, we fit a variety of different distributions. And then we check to see which distribution describes the data best. And it turns out that the log normal distribution for every single person describes the attentional process engagement with the phone. And that maps onto the way that attention has been looked for other media as well. Looking time at television, looking time at reading books, the production of blog posts, the engagement with email. These are all sort of log normally distributed. So the implication here is that the smartphone is not acting differently as a kind of technology than other media and attention engagements are. Okay, then we can pull out for every single person what their particular distribution is, and we have a way to study inter-individual differences in the sort of switching rate of people. And in our first studies, it was Stanford undergraduate students, and the average time that a person spends in a given activity is about 20 seconds. So imagine if you are writing a term paper, you are writing your term paper in these very short segments, and then you'll be in Word, do something, you'll switch to Google, you'll switch back to Word, you'll go to Facebook, you'll go to Snapchat, you'll go back to Word, you go to Google, and these switches are happening constantly across time. I myself have tested, and I'm also a 20-second person. That's how my switching works as well. Okay, so we also want to highlight then that even though the overall distributions of the attention segments appear to have the same distributional shape across persons, that they change very differently across the day. So this is the hours across the day here. The gray in the background indicates where we have the most data. So in the nighttime, we have the fewest observations of people on their phone, presumably because they are actually sleeping during this time period. But we see that these massive changes from hour to hour in the speed of engagement, the attention which is being given to the phone, the switching rate. So the implication here is that that mean doesn't describe anybody's actual behavior. So we should not be paying attention to the mean, but we should be going to this person-specific level, as it were. Okay, we can look at the velocity of text, the velocity of graphics. In each case, we see these massive between-person differences and massive within-person differences as well. So nobody's following straight trajectories. There's lots of heterogeneity in how people are engaging here. And part of that is because what these devices offer us is that they offer us a pause button. So now with any particular activity that we are engaged with, we can press the pause button, we can go do something else, and then we can come back and hit the play button again. So nobody watches movies straight through anymore. We pause, and then we go have dinner, and then we come back and we watch the rest of the movie in there. And then we're doing that on a very regular basis now. And that seems to be sort of giving people a lot of agency in how it is that they are engaging with the world that then increases the heterogeneity. We think that's the idea here. Okay, let's just do one more piece here with the local temporal structure. So we looked at the global temporal structure. Now we'll look at the local temporal structure. So here's one person's attentional deployment. And we can think of that as a tension between interest and boredom, and that those are competing against each other. So when is it that a person switches here? So notice this is text editing is here in blue, and the median time spent in text editing is 144 seconds, so that's about 2 minutes. So this person is writing, and they're writing for a living because they're a professor, is doing that in 2-minute segments, and write for 2 minutes and then switch and go do something else and then go back to that. So we can look at how it is that the different types of activities are engaging and for the lengths of time that those activities are engaging with these competing goals. That might be a way to also do some phenotyping of times when a person is concentrating better or worse than others, however that becomes defined. We can also look at the emotional content. So 2 different theories, emotional inertia, that negative emotion will persist, and that would be a negative thing, a negative for health. Another view is the functionalist view of emotions, that the negative emotions are signaling novelty and a need for action readiness. So I need to pay attention more when things are negative. And this appears to be what's happening in the analyses that we've done so far, that if there's a lot of negative emotional content on the screen, that then people will pay attention to that screen for longer. And that, I mean, notice it's only a few seconds longer that's actually occurring, but that does give an indication of why it is that the negative aspects of content that we see in the news today are so pervasive, because that's the novel thing that our brain sort of evolved to do that, perhaps, and that's why it is that the news has gone in that direction. Okay, this all leads us to this idea about doing person-specific analyses, and we got interested in what is the intentional thing. So do I pick up my phone with some intention of doing a particular kind of activity? For instance, a social media check-in. That means that I would in a given session, I would work with a couple different applications, and then in a separate session, I would do different things with different applications. So we started looking at this species co-occurrence. So the basic idea here is, are there certain applications that play well with others? So they can live together with other applications, or are there some applications that are predatory in that they only exist by themselves and they would eat up all the other apps and only engage with those apps? And the message which we've gotten so far is that Facebook is really constant in most of these things, and it's totally idiosyncratic. So that the ways in which people are engaging with the different applications they have on the phone is not homogeneous, but that people do have some structure to that. It's just an idiosyncratic structure across persons. Okay, I just want to highlight this one here. This is a lock screen at the bottom, and the lock screen does not play well with others. And this is, we think this is the activity of looking at your phone to check the time. And that's all you do in that session. So that becomes a session on its own, that you're not doing other activities along with checking the time on the phone. Okay, that leads us to application, because we're working with categorical time series data here, of creating Boolean networks. And our idea here was to try to identify attractor spaces where if I pick up my phone, I would end up in a particular kind of activity. So if you take one of these green dots, as if I enter into my phone here, then I will get led to this loop of an attractor where I would spend the majority of my time. And that, in this person's case, is gaming with friends. Whereas if I enter into my phone at this case, then I would go into a music listening activity. So the idea here is to try to separate out, to identify what these different activities are, and then also understand how it is that people may move from one activity to another. So if we want to optimize the way in which a person travels through the different activities, we can think of it as sort of a subway train here. Then there's certain stops when I can switch trains in order to get to the activity which I want to. And there's other places where I can't get off this train. I'm stuck on the YouTube black hole type of train. And so as an intervention, then we would want to create extra places where a person would be able to switch from one activity to another. So can we identify an intervention that would allow me to, in some optimal way, move somebody from a from an undesirable attractor state into a desirable attractor state? And that would be an idiosyncratic intervention for each person. And the reason I say that is because the networks look totally different across people. So the types of activities that people are engaged in, where those attractor basins are, is different for every single person. And that leads us to the need to be able to provide person-specific interventions that might help that person optimize. Okay, so I'm going to finish up here. Three things that we talked about. I introduced Screenomics and the idea that digital life is life. If we can get this record of life, then we can study all different aspects of behavior that humans are engaged in. Thinking about small data and big data and how there's a crossing between the methods which might be used in these two different approaches. And then highlighting some of the ways in which our examinations of the temporal complexity that's embedded in massive time series, high density data, and using those in order to develop new theory and empirical work. So thank you very much. Please visit us at screenomics.stanford.edu. Pleasure talking to you all.
Hi, Nilam, that was an amazing talk.
Thank you.
Aaron, I see that you raised your hand, but I'm a total newbie, so I don't know what that means. Maybe it means you can ask a question for real. Lucina, you too? Wait, they're coming in.
Okay.
Oh, so the first question, Nilam, I don't know if you can see them. I'll read them until you tell me to stop. How can other researchers get access to this data?
So this is a very complicated question. So we are collecting the data in a HIPAA compliant zone, and it's all stored in a very secure way. And we have assured our participants that all of the private aspects of those data will only be looked at as a select set by a select set of researchers. And what this has done is it has changed the way in which we're thinking about trying to do data sharing, and has raised a lot of ethical issues about how it is that such data sharing would happen and what it is that other researchers would be able to do with these data. And we've engaged with the bioethicists to try to map some of the ways in which genomics has been used onto this screenomics space. But currently, we don't have a good way of doing the sharing because of all of the private data which is in there. We've put ourselves as in a different camp than the big data houses in the way in which we are engaging with this type of data. And what that means is that we need to engage in collaborations, and we're very willing to engage in those collaborations. And the hurdle is at the level of the paperwork that has to be done in order that the institutions are okay with each other's security arrangements. That's basically where the hurdle is. But we're happy to try to build the collaborations. And as we get more traction on the ethical pieces of this, we're hoping that we will be able to develop a repository. The Human Screenome Project as an idea is to develop a repository that lots of different types of researchers would have access to. But we're not there yet, but we're trying to get there.
Super. So I think you have a potential collaborator. I believe it was a name I mentioned, but even though it goes by the name of anonymous something. So stay tuned for paperwork. Thank you.
Okay.
So Lucina says, really interesting work. Thanks. Do you see this as possibly having applications to mental health interventions in the future?
Yes, absolutely. So currently there's a lot of work being done on how is it that other signals which are coming in from smartphones, such as GPS location, the number of phone calls that a person makes, the number of pickups has actually been one. So is somebody picking up a lot more than usual? Amount of activity which is occurring, and those are being used for mental health phenotyping. And the piece that, so what we've started to do is to take, we'll just give one example. We've got bipolar disorder as defined by DSM, and you can take the symptoms of BPD and map them onto particular types of behaviors that we would be able to extract out from the screenome data. For instance, the switching rate may be an indicator of different types of mental states, and that would map onto a mania type of expression if we could get it down to that precise way. And the beautiful thing about this is that you can learn from what a person's own baseline is when it is that then they deviate from their baseline, because we would have such a rapid data. So we're trying to do those mappings in this top-down way to take the symptomology and map it into metrics, which we are already able to extract. And the other direction, we're also trying to figure out how to do, and that we would get a sample that has psychopathology and try to do prediction from our time series data streams to be able to predict the particular states that a person is based on self-report, for instance.
Super. So there are 3 questions up. So one that relates to that, and then I'll loop back, is Aaron is noting that in his research, novelty seeking operationalized through GPS tracking, right? So the amount of new information that I cover in my travels seems to be related to goodish things at a neural level and perhaps at a theoretical level, but Aaron wonders if there can be too much novelty seeking. And I think you just answered that question, but if you wanted to add anything else.
Yeah, so we have also looked at the metrics which are being used in the GPS space. So say, for instance, what is the 95% confidence interval around? So how big is my physical space that I move in the physical world, and try to map that into the digital world. So then what is the digital space that I move in? And some people will have a small digital space. They visit the same types of locations over and over, versus someone might have a broader digital space that they visit different kinds of locations over and over. And that's a harder problem than we thought it was going to be, because the multidimensionality of the digital space doesn't map well into latitude and longitude. So we don't actually even know what those dimensions are that we should be calculating that space in. And I think that there is this idea about novelty. We have some work on appetites, people who are hunters versus gatherers, as a general characterization in the media world, about whether I'm hunting out different kinds of media versus I'm letting stuff come to me. So that might be one direction to go in, is sort of how do personality types express. But I'm thinking that now I lost my train of thought in there, that novelty, that the actual content of what it is that I'm looking at is something that we've never had access to before. And trying to figure out, for me, what is novel content versus somebody else, what is novel content. So if I program in R, so if I start looking at pages which are about R coding, that's not novel for me, even though that's a relatively small thing that's out there in the internet. And it might look novel at the group level, but at the individual level, it's not particularly novel. So I think trying to get this sort of baseline idea of what are the topics which I'm interested in, and how is it that interacts with, how is it that new information comes into that?
Yeah, so Nick asked a question up, how do you identify groups of behaviors? And I think you're speaking to that, and also to the tension that you've denoted throughout the talk between individual and group level analysis. So could you speak to that a little bit? Like, where are you with that? I mean, don't we want to know for groups of people?
Well, we sort of got into this from the idea that we wanted to be able to do person-specific stuff. So as a data analyst, I wanted to have long time series within person, and acknowledge that those long time series within person are unlikely to be stationary. So they're going to be non-stationary. And if one sort of starts off from that perspective, then one gets into these data and says, well, I have no idea how to take Daniel's screenome and my screenome and match those up with each other. And so the formation of groups in a bottom-up perspective, I don't know, I'm seeing more and more that maybe I shouldn't be putting screenomes together, and I really should be treating each person as idiosyncratic and different from other people. At the same time, the top-down models are I start with a unified population and I start segmenting it into groups. Eventually, I would end up with each person in their own individual group. And trying to find the middle ground between there is, at this point, almost driven by field specificity. And if I am working in a field that is already acknowledging between person differences, or if I'm working in a field that does not look at between person differences generally. At a gross level, one could think of this as, am I working in a sociological content area, or am I working in a psychological content area?
Yeah, so this brings up for me, so two things. So Raphael says bravo about looking at the person-specific stuff and applications that include mental disorders, and this n=1 idea that I can then maybe use your algorithms to look at my own data and figure out, oh, you know, I need help, or whatever the case may be. So then a meta question, which is like, I mean, the scale of the creativity is just unreal. And I sometimes use this analogy, but I see that I should be using it for your work, which is like, you know, we had seen people's digital lives from afar through like Nielsen ratings and so on. And that's like conventional astronomy. You know, we look at Mars with a telescope, we can see Mars, we're seeing Mars. There's lots to learn. But now, like, you've taken a rover to Mars, and you've landed there, and you're seeing the days and the nights and the rocks, and it's very, very different. There's a lot more data, there's a lot more close up. So with that analogy in mind, how do you like like you were talking about sociological fields versus psychological fields, you have fundamentally new data. In some sense, the field that you're working on is not yet a field. Like Screenomics, I have to break it to everybody. I think you made it. So how do you I don't know, do you just do the work and then the theory comes in, and I can see you're super open to collaborations with different groups of investigators who have unique things to say about the data at different levels. How do you handle it all?
Yeah, so there's a practical element to this and also the discovery element, in that we do believe now that we've seen these data that there are a lot of theories that can be rewritten or changed because now we have a different view on the problem. We didn't know that people were switching as rapidly as they are. Even the app creators didn't know that people were switching as fast as they are. So that makes us start to think about attention processes in a different way, and maybe we will develop new theory. So we are engaged in a lot of sort of bottom-up work, and without it, it's not totally clear to us where that goes, but we're open to the idea that we're discovering and we're going to develop some new theories. And one of my colleagues likes to say that much of what we know so far is probably irrelevant to what it is that we're doing now. And now we can try to come up with a new theory, given that we have this new kind of data. At the same time, and our students really struggle with this, is that in order to publish papers, it's often that we have a theory, you have a research question, and then you do some confirmatory analysis in order to be able to answer that research question. And the journals are more receptive to that kind of work. And so we're simultaneously trying to use these new data in order to be able to test existing theory and hypotheses that are derived from those theories. And then in the discussion section, talking about, well, maybe the theory could be revised now that we have learned this piece. But we're really feeling this tension. And it often manifests in the different career levels within our group, and what the needs are for the publishing aspects of those different career levels. The difficult one.
Yeah, no, that makes total sense. I'm going to respect the time limits and just confirm for Joseph that if folks want to collaborate, should they just email you?
Yes, reach out to me. We are happy to engage in those conversations and look forward to it.
Okay, well, Nilam, thank you so much for a fabulous iDisk data science, data citizen talk. It's been super interesting. I can't wait to catch you next time.
Thank you very much for the invitation. It was a pleasure talking to you all.
It's really fantastic. Thank you. Take care.